Centrifugal pump basics. How centrifugal pumps work. Working principle. Hvacr. Pumps are devices used to move fluids, liquids or gases, from one place to another. They are widely used in various industries and applications. Pumps can be classified based on several criteria, including their working principle, construction, and application. Here are some common types of pumps. Centrifugal pumps are widely used in various industries, including Hvacr, heating, ventilation, air conditioning, and refrigeration, to move fluids through a piping system. The working principle of centrifugal pumps involves the conversion of mechanical energy into kinetic energy in the fluid being pumped. Here are the basic components and principles of centrifugal pumps. Centrifugal pumps. Radial flow centrifugal pumps. Fluid enters the impeller axially and is discharged radially. Axial flow centrifugal pumps. Fluid enters and exits the impeller in the axial direction. Radial flow centrifugal pumps are a type of centrifugal pump where the fluid enters the impeller axially, along the axis of rotation, and is discharged radially, perpendicular to the axis of rotation. These pumps are one of the two main categories of centrifugal pumps, the other being axial flow centrifugal pumps. Here are the key features and characteristics of radial flow centrifugal pumps. Impeller design. Radial flow pumps have an impeller with curved blades or vanes. The impeller spins on a shaft, and its design is such that the fluid is forced outward in a radial direction. Fluid entry. The fluid enters the impeller at the center, near the shaft, and is directed towards the outer edge of the impeller by the curved blades. Centrifugal force. As the impeller rotates, it imparts centrifugal force to the fluid, causing the fluid to move radially outward. Pressure increase. The radial movement of the fluid results in a pressure increase. This pressure energy is then utilized to move the fluid through the pump and into the discharge pipe. Applications. Radial flow centrifugal pumps are suitable for applications where a moderate to high head pressure is required. They are commonly used in situations where the pump needs to lift water or move fluids against gravity. Advantages. These pumps are generally more efficient at higher head conditions compared to axial flow pumps. They are versatile and can handle a range of flow rates and pressures. Discharge. The fluid is discharged tangentially from the outer edge of the impeller into the volute or casing surrounding the impeller. Common uses. Radial flow centrifugal pumps are employed in various industries for applications such as water supply, irrigation, boiler feedwater systems, and other situations where moderate to high pressure pumping is required. Efficiency considerations. The efficiency of radial flow centrifugal pumps is influenced by factors such as impeller design, rotational speed, and the characteristics of the pumped fluid. Understanding the specific requirements of a pumping application is crucial for selecting the appropriate type of pump. Radial flow centrifugal pumps are well suited for applications where the emphasis is on developing higher pressures rather than large flow rates, making them valuable in scenarios such as industrial processes and water supply systems. Axial flow centrifugal pumps, also known as axial pumps or propeller pumps, are a type of centrifugal pump where the fluid flows parallel to the pump shaft, entering and exiting the impeller in the axial direction. Unlike radial flow centrifugal pumps, where the fluid enters radially and exits radially, axial flow pumps have a different flow path. Here are the key features and characteristics of axial flow centrifugal pumps. Impeller design. Axial flow pumps have a propeller-like impeller with blades that resemble the shape of a ship's propeller. These blades generate thrust in the axial direction. Fluid entry. The fluid enters the impeller axially at the center and flows parallel to the pump shaft. Centrifugal force. As the impeller rotates, it imparts centrifugal force to the fluid, causing the fluid to move along the axis of rotation, away from the pump center. Low head, high flow. Axial flow centrifugal pumps are designed for applications where a high flow rate is required, but the head pressure is relatively low. They are particularly efficient in moving large volumes of fluid with relatively low lift or head. Applications. Common applications for axial flow pumps include water circulation in large bodies such as rivers, drainage, flood control, and cooling water systems in industrial processes. Efficiency considerations. Axial flow pumps are known for their high efficiency in moving large volumes of water, especially in situations where the water level drop head is minimal. Construction. Axial flow pumps typically have a more streamlined and elongated shape compared to radial flow pumps. The impeller is mounted on a shaft, and the entire assembly is housed in a casing. Discharge. The fluid is discharged parallel to the pump shaft, typically at the top or bottom of the pump casing. Variable pitch blades. Some axial flow pumps have adjustable or variable pitch blades, allowing operators to optimize pump performance for varying flow conditions. Common uses. Axial flow centrifugal pumps are commonly used in agriculture for irrigation, in water treatment plants for water distribution, and in various industrial processes where large volumes of water need to be moved with minimal elevation change. Understanding the specific requirements of a pumping application is essential for selecting the right type of pump. Axial flow centrifugal pumps are particularly well suited for scenarios where high flow rates are necessary, and the pumping head is relatively low. Components of a centrifugal pump. Impeller. The impeller is a rotating component with curved blades that accelerates the fluid. It is typically mounted on a shaft. Casing/volute. The casing or volute is a curved, spiral-shaped housing that surrounds the impeller. It helps in converting kinetic energy into pressure energy. Shaft. The shaft connects the motor or driver to the impeller. It transmits the rotational energy from the motor to the impeller. Seals and bearings. Seals prevent leakage between the rotating shaft and the stationary parts. Bearings support the shaft and allow it to rotate smoothly. Suction and discharge connections. Inlet and outlet connections through which the fluid enters the pump, suction, and exits the pump, discharge. Working principle. The basic working principle of a centrifugal pump involves the following steps. Centrifugal force. The rotation of the impeller generates centrifugal force, causing the fluid near the impeller to move outward. Creation of a low-pressure zone. As fluid is thrown outward by the impeller, a low-pressure zone is created at the center of the impeller. Suction. The low-pressure zone at the impeller center draws fluid into the pump through the suction pipe. Acceleration of fluid. The fluid entering the impeller is accelerated by the rotating blades, converting mechanical energy into kinetic energy. Conversion to pressure energy. The kinetic energy is then converted into pressure energy as the fluid flows through the volute or casing. This process increases the fluid's pressure. Discharge. The pressurized fluid is then forced out through the discharge pipe to the system where it is needed. Hvacr applications. In Hvacr systems, centrifugal pumps are commonly used to circulate water or other fluids for heating and cooling purposes. They play a crucial role in maintaining the desired temperature in buildings or industrial processes. The ability of centrifugal pumps to handle a wide range of flow rates and pressures makes them suitable for various Hvacr applications, including circulating water through heating or cooling coils, supplying chilled water for air conditioning, pumping water through hydronic systems for space heating, supporting refrigeration processes in industrial systems. Understanding the basics of centrifugal pumps is essential for maintaining and troubleshooting Hvacr systems, ensuring efficient fluid circulation and temperature control. Regular maintenance, monitoring of pump performance, and addressing issues promptly are crucial for optimal system operation.